Well, I'm Dr. Tara Matise, and this is
Steve Buyske.
we are both from Rutgers University. I'm in the Department of Genetics. Steve is in the Department of Statistics. And we're here today to tell you about a research study that we're doing on the genetics of breast cancer. And we want to talk a little bit in particular about breast cancer in men. And we're so thrilled to have met you, Peggy, and nice to meet you, Brett. And we're really grateful to be able to collaborate with your group and get the word out about our study and hope we could be helpful. So Steve's going to do the first part and I'm going to do after Steve.
Actually, you're doing the very first.
Oh, I'm doing the very first part. Okay, great. Well, the very first part is one slide where we're talking all about our study. So as I mentioned, we are looking at the genetics of breast cancer. This is an online study that's very easy to enroll in. And I know, Peggy, you've already blasted this out a couple, at least once or whatever on your social media and your email group. And thank you so much for that. But we're still looking to enroll lots of more participants in our study, including men. The only eligibility criteria are that you be 18 or older and you live in the United States. You do the study enrollment online, and it involves reading a consent form and signing it to indicate that you understand what the study is about, completing some surveys online. Oh, look, Peggy's got the flyer. Awesome. And then you'll request a saliva collection kit, which comes out to you in the mail in a little box. And inside the box is a tube. And you spit in the tube and you put it back in the box and put it back in the mail. And that's all prepaid. So there's no cost to you. And then coming soon in the future, we'll have an option for study participants to link their electronic health records if they want to, which helps to better inform our study. And also the option for you to get information back about your ancestry, which is our incentive or thank you for participating in the study. And then we've got the link here for the study. So that's the basics about our study. I think a little later I have some slides to just tell you a few more details about what we're looking for. But Steve's going to take the next part and tell us a little bit about genetics of male breast cancer.
Oops. I think I am. There we go. Okay. So before I start, I thought I'd mention that I've had cancer 4 times, 4 separate occasions, not breast cancer, and I benefited from the people who had participated in research studies, before me, and so I was very happy to participate in some studies myself, well, maybe, stick with that. So, okay, so just talking about the genetic predisposition to male breast cancer. So what we know is not a huge amount, right? So genes can increase the risk of breast cancer in both males and females. It's a lot of the cause of breast cancer in both groups is not involved with genetics, but there is certainly a genetic component. In male breast cancer, there's good data of about 5 genes, BRCA1, BRCA2, and then 3 others that are sort of less well known and have not as strong effects. So less important, I suppose you might say. Now, all of those genes are also known as genes that are important in the development for breast cancer in women. And the details of just how strong the effect is differs a little bit among men and women, but and also these genes also appear to be associated with other cancers, and then so some men have a family history of breast or other cancers, some don't. You can have you can have a higher risk of cancer from your genetics without it necessarily showing up in your family, because we're not talking about things that are 100% or 90% or anything like that. And so so family history of breast cancer increases the risk, and for what's essentially a rare disease, male breast cancer, a family history of male breast cancer really means that, you want to consider that your genetic risk of it. So that was what we do know. What we don't know is what other genes are important in breast cancer, and specifically male breast cancer, and what genes or what variants in genes are protective. Because we often think of like, oh, here's something that's a risk for a disorder, but there are variants that protect people against disorders. Those are Tara's going to touch on this perhaps a little bit later, but those can often be very important drug targets, right? If you can have a drug that mimics what how some genetic variant changes the protein that's that a gene helps produce, that can mean that you can get a pill version that does for you what other people got via their genetics. The one thing I think I left it out on that last slide was that we know a lot less about male breast cancer than female breast cancer, and that has to do with what's on this slide. So one approach has been to look at the genetics is you look at genetic variants that are known. Those are all known because of female breast cancer. And then whenever you have a male breast cancer patient, you test those as well as against some controls who don't have it. And that's how we know that BRCA1 and BRCA2 variants, well known for increasing risk in female breast cancer, also increase risk in male breast cancer. The second approach is sort of a neutral approach, which is say you're going to look across the entire genome, so maybe 10 million different locations in your DNA. And look for variants that might be associated with male breast cancer. So you're essentially just saying, okay, here's a particular place. I'm going to make a little table. People with male breast cancer, people without it, and with this variant and without it. So like a little 2x2 table. Do the numbers look striking? Do that 10 million times. That's why statisticians are involved. And so that can help you find something that's unknown. If there are variants that affect, they're important for male breast cancer that are not related to female breast cancer, this is how we would find them. And that is what we're doing. Now, the reason that we don't know more than what we know is basically because you need to have big sample sizes to do this. And you need to have lots of cases. And the biggest study done so far had a total of 2,200 cases. And they're all British. And so to understand more, we need more cases. So any increase helps. We can combine our results with this other study and things like that. But it's basically a game about numbers. There's game is not the right word, but there are roughly 2,700 new cases in the U.S. every year. If 10% of those people joined our study, from people over the last 10 years, we would be comparable to this one in Britain, and so that's part of what our study, which is looking at breast cancer both in men and women, but it's designed to be really easy to do. It just takes answering questions online. It's less than 20 minutes. Spitting into a little tube, and then you're sort of good.
What would be a better study size? Roughly.
As a statistician, I always want more larger sample size. If we could get 2,200, that would be fabulous, because it's doubling the size, right? We're not, we don't compete against these other groups, or we share information. So doubling it would be would give us new insights. And there's always, sometimes you get the insights from just a small number of people who have a rare mutation. And there's always the case that, if we all we need is the right 7 people in there. But, you need a lot of people to, get those right 7 people. And then there's a paper that, this is a scientific paper, but, this would, I know you can, people have probably been able to, have found things, sort of general audience pieces about genetics for male breast cancer, but this is a more detailed one, if any of your audience might be interested. Back to you.
Okay. So any questions at this point?
Yeah, I've got to say that this was very simple and easy to do. I shared it with family members and I've asked them all to go do it. And hopefully have you gotten much response from any of our men?
So I don't know whether we're tracking people that came in specifically through, through the organization.
Yeah,
We do have, I think it's 15 people so far so men, who have had breast cancer. And I'm pretty confident that would be zero if we,
right. So if I'll just keep on a regular basis sharing this back out is what I'm going to do. And you all have to let me know if you're getting responses or not, because we're coming to the holiday season. And what a better time to talk to your family about doing this type of test and stuff to help make change on the way all these different cancers are treated. And if you all are getting, doing the knowledge and doing this trial, why not? And it's just a matter of getting people to order. I mean, even if you have to be the one to go sit, or after you've talked to your people at the dinner table, pull up your computer and say, let's order you one.
That's right.
Do
and
it.
It is an empowering thing to do. It's a positive step that you can take, and it's a small contribution, but it's a genuine contribution. Yeah.
Absolutely. And so what is this going to the saliva? What will this explain to you all for the study as far as men, women doing it? And if we get more men involved, I think that's going to help you out tremendously too.
Yeah. I mean, we hope that it will help us understand better the 5 genes we already know about. Each gene has many different variations in the gene.
Right.
We used to call them mutations, but now
right.
we use the word variants. And each of them have a different risk profile. Right. And then there are probably a lot more than the 5 genes. Well, we know that there are.
Yes.
So we're really trying to find more genes, understand more about what they do, how they change the risk, whether it's increasing or protective. And ultimately, that information could lead to new treatments or better diagnostics or both.
Very much so.
That's the outcome.
Yeah. And our family is one of those families, okay? Because genetically, we have no mutations per se that cause breast cancer, but I have 15 other women cousins with no mutations, unexplainable, all with breast cancer. So your test and study is going to help change that for my extended family.
In theory.
That's our goal.
Yep. The more people, and the more people enroll, the better the chances are we can learn more information.
That's amazing.
I see that one of your guests has a question, but I'll just, I do also have a couple more slides. They're not critical, but let's take questions.
This is a real quick question. I want to send in a spit sample to you, but are you making note of what people were in the military? Because the military did a test and they told me, well, it's not genetically related. I'm like, what else is in the test? And they wouldn't tell me. So I'm trying to, if you're tracking, if your participants are military related or not.
That's not something that
I don't think we have a question on that. One of the things about doing a study is you have to make the balance between asking, everything that might be relevant versus, I only want you to need to spend a certain amount of time. But when they told you, it wasn't genetic, what presumably they meant was that it didn't show up on their existing panel. And so, that's sort of what I was saying about like what we don't know is because I'm confident that there are variants that are important that we haven't detected. And I think I left this out of the slides, but there are enough differences in men's and women's bodies that I'm sure that there are variants that are important in men that are not important in women. And that understanding those, so that's not going to be on any panel that somebody might have. And understanding those may help both help understand the biology, but help, drug companies like position, figure out, here's a medicine that's going to be useful for various purposes.
Yeah, that's a good question though. I think the only other slides I have, well, they do talk a little bit more about our long-term goals, which I think I just summarized. So I can go through this pretty quickly. Imagine you were told that you were at high genetic risk, but instead there's a medication you can take that would lower your risk. That would really be valuable to you. Or being told you have a variant that suggests it's likely to develop, but again, instead there's a drug you could take that would help your treatment course. So those are the things we hope to help inform over time. And this last one just points out that although we do know about those 5 genes, 2 of which we talk about a lot, there's still so much more for us to learn. Let me see what else I haven't talked about a little bit. There's a little bit on this slide about genetics in general. Everybody has about 50 or so new variants in their bodies that they did not inherit from their parents, but just happened by accident. Over time, through generations, some of these increase in their frequency in the population, or they may decrease. But the way they change can change differently in different parts of the world. Some can become quite rare in some parts of the world, or more common in other parts of the world. Some of these will have no impact on cancer, but some could. And I'm going somewhere with these points, which is really the bottom line, is that we need to have a very diverse collection of people in our study. All science, especially genetic science, really needs to be inclusive and include people from all different ethnic backgrounds. Here's what can happen when you don't. And this is just one example of many in the past where the primary group of people that was studied were white Americans or people of European descent, Europeans, for example. And this is an example from cystic fibrosis, which shows the percentage of false negative results in prenatal testing. So this is when couples are going to have a child and they get their prenatal testing done to see whether they are at risk of having a child with cystic fibrosis. What is the chances that they get a false negative result, that they're told you're not at increased risk when actually they are? Well, among white people, that risk is pretty low. Among Hispanics, among Blacks, among Asians, it's much higher. And why is that? And even among Native Americans, it's higher. And the reason for that is because the people who are studied the most are white people, and we know the most about them. So we don't have the information that we need to accurately do this kind of test in all these other very important groups of people. So the next couple slides I'm going to skip over because they just kind of rehash the same point. We really need to be inclusive of many different population groups in our genetic studies. This one just points out that the largest study of the genetic risk of breast cancer that's ever been done, this would have been all women, had 120,000 cases, which is a huge study, but only 8% of them were primarily African ancestry. So again, that group of people were left out of the study. They are left out of the results. They are left out of the value of the study. I think I'm going to skip over this one. It's just kind of saying the same thing another way. So in our study and in a lot of our collaborators' studies, we're here actually at the annual meeting of the American Society of Human Genetics. So we're in Denver today. We live and work in New Jersey. There are a lot of people here talking quite a bit about this problem and what we can do to help our studies be more inclusive. That's kind of what this slide is about. And this is our last slide, just again, putting out our pitch for you to join our super easy to participate in study. So I think that's what we have.
That's amazing. Like, you were talking about, like I say, we don't have anything yet to prove why all my family members are getting breast cancer. But because I am such high risk, and mind you, back in the late 90s and early 2000s, I had 2 lumpectomies, all benign, no breast cancer. But since I am so high risk because of Brett, 5 years ago, the oncologist that was treating Brett and I, she suggested, Peggy, we don't know if this is going to work or anything, but if you're willing to go on a cancer drug, it'll give us some new information on a study to see if this can prevent you, who will most likely come down with some form of breast cancer, from getting it. Will you do it? And I said, yeah. So I've been on a Arimidex. Since then, I will go off of it the end of this December, will be my 5 years of treatment. And this is what they've studied, because so far, thank God, even though most of the women in my family that have gotten their breast cancer have been in their late 60s, early 70s. I'm 72 now. So maybe it didn't. Maybe it's worked. Maybe that's why I haven't gotten it. But I don't know. But this is what they've wanted to study. Myriad Genetics and CGen and all them wanted to see if this would make a difference, because we couldn't come up with why all my other women cousins are getting the breast cancer at this age. And so far now, I have not. And the oncologist says, I want you to finish out the Arimidex, but at the end of December, you'll go off of it. And then we're just they monitor Brett and I every 6 months. So
Well, fingers crossed that you stay negative.
You and me both. But it's just like you're saying, knowledge is power here. The more we can learn through all ethnic groups, the better we're going to have this. And both my parents, I think I shared that with you, Tara, that they were from Lebanon. They were second cousins, got married, but that's what you do in Lebanon. You marry your cousins. And I think that this is half of the issue with all the women cousins of mine coming down with these breast cancers, because the blood was so thick. And who knows, it's people like yourself that'll discover and figure that out.
It could play a role.
Because it still goes on in Lebanon today. Most people or women, when they were born, just like my mom, were told who they were going to marry. And it still goes on today in Lebanon, Beirut, because it's just it's their belief. They want to keep the blue blood going or something to that effect. But it's like, I told Brett, I said, yeah, I was literally third cousin to my parents. And that's scary. But I did a family reunion this summer, and it's not only us, it was all the other cousins on both sides of the family. We're the same. And I said, they go, so you mean I could be cousin to my parents? I said, absolutely. Just a matter of what degree, 5th, 6th, 7th, or 8th cousin, because that's what was done in Lebanon, and it still goes on today. But I think it's causing a lot of these cancers too.
I think it could increase the risk. We don't know.
Nobody knows. Yeah.
I mean, it would be very interesting to study.
Very much so. Well, we're here, and I've got the family members.
What's the moral of that story? Don't marry
your cousin.
I'm going to
When we
keep
sat
Go ahead.
we sat with my oncologist, or not the oncologist, geneticist, sorry.
Geneticist.
And my parents pulled, I don't know how many years of family history together in 2 days to try to sit down and figure out how I could have been diagnosed and everything. Once my mom started saying, well, my parents are first cousins and all this stuff, the geneticist just goes, Peggy, stop. He goes, I got it. All right, no more. Moving on. So.
Yeah, it's true. Once you have that general information, all the details probably don't add that much.
Yeah. More. Then he said to Brett, don't marry your cousin.
It's a fair point. Yeah. How many people were at your reunion? I'm still blown away by that number.
I had 142 people at our reunion. And these were all cousins from all over the United States, one from Germany too. He came back. And I started just explaining it to him. I said, knowledge is power. Know your body. If you find something, do something about it. Because it won't go away, but you most likely will go away. And be on top of your body, because you're the only one that lives in it. You're the only one that knows. You know, Brett had it at age 17. He shows it. He really didn't show it to any of us or talk about for 7 years. He didn't do much about it. And it's like all the doctors said, he's just damn lucky to be here on Earth because he had discharge from his nipples. He had, go ahead.
One nipple.
One nipple. One nipple he had discharged. But the reality is, you know, he showed it to his dad. His dad sort of tried to say, oh, it'll go away because men don't get it, you know. But reality is men have breasts too, and know your body. And if you find something, do something about it. Don't just think it'll go away. But that's our whole hope. But your knowledge is great. And like I say, with the holidays coming up, everybody needs, you're not going to show it. Everybody needs to get this kit and tell your family members about it. They're perfect. And get your family members to order it. It's on our brother's page. I'll actually send it out again as an email blast to everybody. But
thank you,
Brett. I don't think did you take the test finally or not?
Nope.
No, he hasn't done it. So I got to get him on it and get all my other sons on it and get it all taking the test. Guess what, guys? It's a total free of charge. Very simple to do.
Yeah, and we really would love to get more men in our study. If we get enough men in our study, we can do some focused work on male breast cancer. So, and we would love more.
So we need to press this and talk to our family members and get you guys doing it. That's just going to be the answer, I'm telling you. And like I said, it was very simple for me to read. The instructions were easy. I knew how to do it. I did it quickly, and I got it right back in the mail. And it was awesome. It was just amazing. So I can't thank you guys enough for finding us, and we're getting together, and hopefully we're going to help make that change with everyone.
Well, thank you so much, Peggy.
Yeah. Any other questions? Does anybody have before we go? Nothing? Okay. Well, God bless and have a wonderful holiday, and we'll keep in touch.
We will. Thank you, Peggy. Nice to meet you.
Appreciate having you
everyone else
both.
on the call today. Thank you.